So the first objective is your multi-step. Remember that's half no calculator, half calculator. All of the problems on the first page are multi-step. Are there any of those you want to see you go over? Have questions about? Any others on this page? And that will be our 4 for the multi-step, and we'll move on after those. Okay, so for number 2, we will need to distribute first. So 8 minus 3k minus 6 equals 2 minus 3k. Combine like terms on the same side, do exactly what it says. 8 minus 6, so 2 minus 3k equals 2 minus 3k. What do we notice about this? They're the same. Do you remember what happens when they're the same on both sides? Not no solution, but the other one. Infinitely many solutions, yes. So if you see that, you could stop right there, say this is going to be IMS. If you would like to keep solving, you could also do that. So we could add 3k and subtract 2, and everything is everything. Now, if you're doing it one step at a time, let's say you move the 3k's and you get 2 equals 2, that's also infinitely many solutions because the variables cancel and they equal on both sides. If the numbers were different, so 0 equals anything else, 2 equals anything else, everything is the same. Right. Number 3, we're distributing this -1 to everything here, and the 2 on the other side at the same time. So 3w minus 7w minus 12 equals 2w minus 6. Make sure you're distributing to everything. Combine like terms on the same side. -4w minus 12 equals 2w minus 6. Here, because we have different coefficients, this is going to give us one solution. So then we have choices. What do we want to move first? The 2w, okay. So if we subtract 2w to the other side, we have to move 12 back over. So we have -6w equals 6. Divide both sides by -6. So that w equals 3. For sake of time, we're not going to put each number back in, but remember that on the calculator section, you can take the number, put it back in, see on your calculator, do you get a 1 or a 0. Questions on 3 before we move on to 5? 5, we have more distributing. 9n minus 36 minus 7n equals 32 minus 2n minus 16. A lot of subtraction in there. When you have multiple negatives, double check your math, make sure it's supposed to be a negative, not a positive. Combine your like terms on the same side. So 2n minus 36 and 16 minus 2n. Again, we have different coefficients, so this is going to equal one solution. What do we want to move first? Which one? The 2 or Again, if that's not what you want to do, you do have different options. You don't have to do the same thing as long as you're doing the math correctly. If we subtract 2n over to the right, we have to subtract 16 to the left. And divide everything by negative. And should be 13. Questions on that one? For number 10 or any questions similar where you have a fraction that equals another fraction, what is our first step? So that means taking the numerator, multiplying it to the opposite denominator, and vice versa. You don't have to do this part, but you have to know that part. So we have 6 times n minus 7 equals 2 times 2n minus 5. Whether you put the 6 times all of this on the right or the left doesn't matter. Then we can start to simplify. Distribute 6n minus 42 equals 4n minus 10. We have choices. What do we want to move? If we're subtracting 6n to the other side, we have to add 10 back over. We have negative 32 equals negative 2n. Divide both sides by negative 2. Any questions on 10, on solving multi-step in general? Let's go on to the next page. So there are more absolute values than just these 4, but do we have questions on 11 through 14? So number 13, we would need to isolate the absolute value, get rid of the negative 4 by, right now it's multiplying or it's right next to you, so we can divide both sides by negative 4. Remember that once you isolate the absolute value and if this number were to equal a negative, it would be no solution. But because it equals a positive, we can keep going. Drop the absolute value, set it equal to a positive and a negative 8. Remember that if you don't do this part, you're missing half of your work and half of your answer. Solve both equations, subtract 6. And divide both sides by 2. So w equals 1 and negative 7. Write that as a solution set, least to greatest, in curly brackets, with w equals out front. W equals curly brackets, negative 7. If no other questions between 11 through 14, look on the next page at 5 and 6. Questions on those? So we're going to do word problems when we get to word problems. If no questions on 5 and 6, fine, skip a couple pages. Until you see 7 and 8 at the top. And look at numbers 9 and 10. Either of those you want to see, do go over and have questions about. If none of those, not the back of that page, but the next page that looks like any of those, 1 through 8. For number 7, this is already isolated, so we don't have to do that part. We can now just drop the absolute value, set this equal to a positive and negative version of 13, subtract 5 to everything. And then once you get here, you can either divide everything by 1/2 or flip this and multiply everything by 2. So that our solutions would be negative 36 and 6. Questions on that one? We're going to go back to the page we're just on and finish number 10. Or do number 10. But have 7 and 8 on the top. And we're going to do number 10. Okay, so for this one, if we're isolating, we need to get rid of the 1 first. Then you can get rid of the 3 by dividing to the sides. Make sure you're leaving this in absolute value until it's completely isolated, like so. Then you can drop them, set them equal to a positive, negative 6. And solve. So that we get negative 2 and 10, and we have to write that as a solution set somewhere. Questions on that? We can do one more absolute value if needed. Go to the very last page. Numbers 9 through 16. Any questions on that? 1/2 is directly connected to the active value, so subtract on both sides. Then we can get rid of the negative 1/2 by either taking it and flipping it and multiplying on both sides, or dividing both sides by negative 1/2. I'll let you guys choose. And then once it's isolated, we can drop the active value, set it equal to a positive and negative 28, and subtract 9 on both. We have negative 37 and 19. Questions on 16 before we move on. There aren't many literal equations in all of this, but if you go through the pages and find the page where 14 and 15 are on top, those are both literal equations. In hindsight, I should have numbered these pages, but I'm not. Do we have questions on either of those? For 14, we're solving for h. We have to get rid of pi r squared. How could we do that? Divide everything at the same time by pi r squared. So they cancel, and b would be your answer. Alright, questions on 15 before we move on. The last set of literal equations is not on the next page, but the back of the next page. There are 6, 1 through 6. Any of those that we want to see you go over have questions from. Number 3. Let's start with those two. Number 3, we have to get x1 by itself, but it's being added by x2 and divided by 2. What would be our first step? Multiply by 2 on both sides, so that those 2's cancel. Then to get x1 by itself, we could just subtract x2. 2m minus x2 equals x1. Make sure you're showing all the steps, doing everything to both sides. Number 4, we are solving for y. What would be our first step in that one? Get rid of the x term because it has nothing to do with your y. Subtract it to the other side, but you're not combining like terms because they're not like terms. So just rewriting. And then, because this 9 is here, this is going to simplify when we divide, so divide everything. y equals 3 minus 2/3 x. Or if you put negative 2x over 3, that is also fine. Questions on those or any other questions in the literal before we move on to word problems? I want to say I mentioned this before, so the literal is going to be no calculator because most of it is variables anyway. And then half of them also. Everything else will be calculated. With the word problems, since we have some here, do we have questions on 1 through 4? Number 4, so let's read important information. A stack of 18 bricks is 45 inches tall. What is the height of each brick? What is important in this? The 18 bricks is important. 45 inches tall is important. What are we looking for? So we need to start off with a variable. All of your word problems should start off that way. Defining what your variable is, we can call it the height of each brick. Look at your question. That will kind of help you define your variable. We know that the total is going to be 45, so it's going to equal 45. How could we set this up? We have 18 bricks total, and we need to have the height for each. What can we do with that 18 and that h? I'm using h, but if you're using x, that's fine. Right, and then divide. Someone divide that from the together. Right, and then make sure you're putting labels. So these are in inches, so this can also be in inches. Other questions 1 through 3 there? On the back of the first page, there are some more word problems. Don't worry too much about 18, because those won't be on there. But anything else is fair game. So questions on 15 through 17. So this one's good because there will be a perimeter question on the quiz and on the test. So let's read it first. A rectangle has a length 6 inches less than twice its width. If the perimeter of the rectangle is 54 inches, find the dimensions. What is important in this one? The length 6 inches less than twice its width, that entire part. What else? Say that one. Find the dimensions, what we're looking for. Anything else? Perimeter is 54. Alright, so now that we know important things, when you define your variables here, it's just going to be L equals length, W equals width. Unless you change the variables, then it'll be whatever variables you say, but it still needs to be length and width. You can have 2 different variables. talks about the length specifically, so we're going to have a length or a L equation. How could we set that up? 6 inches less than twice its width. Remember that less than is a turnaround, so 6 has to go back. We also need to know our perimeter equation. So P equals 2L plus 2W. If you forget that, you need to at least remember that perimeter is adding up all the sides. The rectangle has 4 sides. So you would take your length equation and add it again, and then your W and add it again. But now that we have our length equation and our perimeter equation, we can take this and put it in for L. And also change P to 54. So 54 equals 2 times whatever L is, 2W minus 6, plus the 2W that was already there. Then we can solve this like a normal problem, distribute. We have 4W minus 12 plus 2W, combine like terms. Get rid of 12 by adding it to the other side. And divide both sides by 6. So our width would be 11 inches. And then we have to go back and find L. How could we do that? What W equals, where could we put that to find L? Back in W up here, so that L equals 2 times 11 minus 6, and then figure out what L is. Right, other questions on that page? To maybe do one more word problem. Which one? 18. Besides 18, because that one won't be on the quiz with us. Come on. 16. Is that what you're going to say? Okay. We don't have time to do both of these, but they will be similar. Well, you may have to wait because this is running slow. So I said this is running slow, so I can't write the passages yet, so you gotta wait a second. Alright, let's take a second and read through this as part of their government class. Maddie and Ryan have to log volunteer hours in their community. Ryan volunteered for 1 more than 3 times the number of hours Maddie did. Altogether, they volunteered in their community for 45 hours. How many hours did Ryan volunteer for? 2 seconds, first. Alright, so what's important in this? faster this will go, the faster you guys can get through your quiz. What's important in this? Okay. How many hours did Ryan volunteer? What else? Together they volunteered for 45 hours. Anything else? More. So we can, because Ryan's hours are based on Maddie's hours, we can set up a variable for Maddie's hours and then go back and find Ryan's. Can we call that? I'm sorry, we need both, R and M. So I can say Ryan's hours and Maddie's hours. Okay, we can set up an equation for Ryan. 1 more than 3 times the number of hours Maddie did. How could we write that? More than 3 times the number of hours Maddie did. So we know we're going to multiply by M. But what's going to be the rest of that? Or 1 plus 3M. Either or. Doesn't matter. And then we know together they volunteered for 45 hours. So we knew what R was and we knew what M was, and we added them together. It would equal 45. Then we could take Ryan's equation and put it in for R. So 3M plus 1 plus M equals 45. And solve for M and then go back and solve for R. 4M plus 1 equals 45. Get rid of the 1 by subtracting. Divide both sides by 4 to get 11. And then put 11 back in to find Ryan's. You also could have put 11 back in this and solved it there. You should have gotten the same answer, so either or doesn't matter. But 34 hours and 11 hours was your answer for that. Do you have any general questions about the quiz before you guys go ahead and start? You can go ahead and clear off your desk, put this away, put your calculator back in the calculator pocket, make sure your phone is in front of the calculator.